Okay, Assalamualaikum warahmatullahi wabarakatuh, and hi guys, welcome to our channel Math React. Me, Muhammad Ifat bin Shamsuddin,
And me, Muhammad Karanul bin Ibrahim.
And me, Muhammad Zikri bin Huzaimi.
will be explaining to you guys about a mathematic equation, which is about optimization. So make sure you guys look at the video carefully so you guys wouldn't miss anything, okay? Okay, now let's look at the question. A rectangle is to be inscribed in a right triangle having sides of length 6 inch, 8 inch and 10 inch. Find the dimension of the rectangle with greatest area, assuming the rectangle is positioned in the figure as below. Okay, so the question asks for the dimension of the rectangle with greatest area. So first, let's label the rectangle first with length and width. Okay, now if you can see, the length of the triangle is 6, 8 and 10 inch. We can see that the triangle has a 3-4-5 ratio triangle, right? Now, would you believe me that the small triangle, the three small triangle, have the same ratio as the big triangle? Okay, now let me prove to you guys. So it's a right triangle, so one of it should be 90 degrees. So let's just assume the another one, this side over here, as 60 degree. So the other one should be 30 degree, right? Okay, now let's look in the figure. Okay, over here 60 degree and there 30 degree. So over here we have a rectangle, so it is assured that over here will be 90 degree, right? So in a straight line we will have an 180 degree over here, right? Yes, 180 degree. So 180 minus 60 minus 90 degree, we will get the angle over here is 30 degree. And as it's a right triangle, we should have over here is 90 degree. So the total degree in a triangle is 180, right? So minus the 90 minus the 30, we will get over here is 60 degree. Same goes to the upper one triangle. We should have the same method. Over here with 30 degree, and in the square we have 90 degree. So beside that we should have 60 degree. With alongside with the 90 degree at the left, so we get the upper top will be 60 degree, 30 degree. I'm sorry. So we should have those 3-4-5 ratio triangle as well, because it have the same angle. It might not have the same length, but we can say that it have the same ratio. It might be useful later on. Okay, now let's say this side is x, so that side should be 10 minus L, which is over here, minus x, right? Okay, so I think that's enough. So now let's proceed to the equation.
Assalamualaikum warahmatullahi wabarakatuh. Okay, for the question that Ifat have told us before, so the first and foremost step we must did to answer this question is we need to find the optimization equation, which is the question asks us for find the maximum area of the square. So we bring out the formula to find the area of the square, which is length times width. And next step to answer this question is we need to find the constraint equation, which is from the triangle that Ifat have drawn to us earlier. That we can find equation x that's equal to 3/4w, and also we can also find the equation for w, which is 3/4 times 10 minus L minus x. And we need to get rid of x, so we can substitute the x with the equation before, and we get w is equal 3/4 times 10 minus L minus 3/4w. And we solve algebraically, and we supposed to get L is equal to 10 minus 25/12w. And then we substitute L into the optimization equation, and we supposed to get A is equal to 10 minus 25/12w times with w. And we substitute and we bring in w and we will get A is equal to 10W minus 25 over 12W squared. And next we find the first derivative of area, and we're supposed to get 10 minus 25 over 6W. And next step, we let A prime equal to 0, and we will get W is equal to 12 over 5.
Okay, Assalamualaikum warahmatullahi wabarakatuh. So, thanks to our brother just now to help us find the critical point for the variable W, which is the width of the rectangle. So right now we have already achieved to a point that we need to know whether the critical value is a maximum or a minimum point. Therefore, we have to perform either first derivative test or second derivative test. In this case, we will do it both, because why not, right? And the first is the first derivative test, which is we draw a number line and then we label the critical point on the line, and then we write the equation that we have already differentiated just now, which is 10 minus 25 over 6W, and we substitute the value of the critical point, which is less than 12 over 5, to the left of the number line, and when we substitute the value, we get a positive, which means it has a positive gradient. And when we substitute the value, which is more than 12 over 5, we will get negative, and the gradient is going down. So that when we draw the graph, not a graph, is basically a sketch of it, we found out that the relative maximum is happen when W is at 12 over 5. And when we do the second derivative test, we just basically take the differentiated equation just now and we perform a second derivative on it, and we will get negative 25 over 6, and the value of that particular number is less than 0, so that means is maximum when W is equal to 12 over 5. So we are done for the width side, and now we have to find the length of it, which is L is equal to 10 minus 25 over 12W. We just substitute the value we found out just now, and we will get a value 5 inch. And the question asks for dimensional for maximum area, which means that they want us to write down the formula of it, the formula area of it, which is length times width, which equivalent to 5 inch multiplied by 12 or 5 inch. So to summarize the things up is that we need to sketch the triangle, and we also need to find the optimization equation, and we have to find the constraint equation which can relate to the optimization equation, and we need to substitute the variable that related in constraint equation into the optimization equation to be differentiated, and we set it into equal to 0, and then we perform the first derivative or second derivative test to indicate whether it is maximum or minimum. So that's it. Thank you.
Thanks guys for watching our video, and I hope you guys understand what we have taught you just now in chapter Application of Differentiation. I hope you can score well in this chapter in your examination, guys. Okay, last but not least, for those who not subscribe our channel, please do well subscribe our channel below, and don't forget to push the like button and leave your comment below. And that's all from us in YouTube channel name Math React. See ya.
Bye. 860. Alah. Alamak.
Masya aku cakap belum ada. Ya.
Kita ada nama channel ke?
Mac React. Aku tengok ada satu rap YouTube Indo React. Mana? Mac React. Teach you what we have told you before. Apa cakap? Mac React. And I hope you guys understand all the information or what we have taught you just now in tak siapa. Aduh.